Today's lesson is 2.2, adding and subtracting fractions notes, and we're in your notes packet, pages 5 and 6. And I know this is a topic that a lot of people really struggle with, but we're going to kind of approach it from a little different aspect to kind of get us started here and to make sure that you kind of get an idea of what's going on. So fractions, we're going to get into them, but let's just take a look at these two examples that we have here. So don't overthink, make this nice and easy. If I have 2 apples plus 2 apples, I'm going to end up having 4 apples. And that makes sense to us. We're totally able to do that. If I have 1/5 plus 1/5, we're going to end up with 2/5. Now, here's where things get a little scary. 2/5 is actually a fraction. But if you follow the same example of 2 apples plus 2 apples, 1/5 plus 1/5, you have 2/5. So I could have also changed these to numbers, which might have made it even easier for some of you, rather than actually having the words here. So fractions are really just another part of a language, and they're really just a part of the language of math that we have here. So when we're talking about fractions, we're basically going to be combining things that are the same. So 2 apples plus 2 apples is 4 apples. We could say 2 is your numerator, apples is your denominator. And if we have 2 apples and 2 apples, we can add them together because they are the same thing. Just like over here, we had 1/5 plus 1/5, we can add them together because they're the same thing. So in your notes packet on page 5, we're going to start off with just what we call common denominators, where the bottom part of the fraction is the same. So I'm going to start off with these number line problems, and we're going to actually we're going to use a number line here to help us with the fractions. Over here, you'll notice I have 0. I'm going to start at 4/10. And then I'm going to add 3/10. So each of these spots on here represents 1/10. So I'm going to start at 4 and I'm going to go 1, 2, 3. And when I add on those 3/10, I'm now at 7/10. This is just like what we saw when we talked about number lines with adding integers way back at the start of the school year. So 4/10 plus 3/10 is 7/10. 3/11 plus 7/11. So we're going to start here at 3/11 and we're going to go 1, 2, 3, 4, 5, 6, 7. And that's going to take us here to 10/11. Take a look at the next one. We can do this with subtraction. Subtraction is just going to have us move to the left because remember, subtraction is just adding the opposite. So adding a negative would make us move left. So if we start here at 2/3 and we add a negative 1/3, that's going to take us here to 1/3. We have 6/9 and we're going to take away 5/9. So 6/9 and we're going to go to the left. 1, 2, 3, 4, 5. It's going to take us to 1/9. So let's kind of make a quick generalization. Did you notice that all of these had the same denominators? In order to add or subtract fractions, you have to have like denominators. So we have 1/5 plus 3/5. Denominators are the same, so it's not going to change, and 1 plus 3 is just 4. A subtraction problem, 7/8 minus 5/8. We are going to keep our denominator, and 7 minus 5 is 2. This I would ask you to reduce to 1/4. Now, the next problem that you see on this page does not have a common denominator with it. So I'm going to ask you to think about this problem before we get started here. 2 trucks plus 3 vans. Can I just add these together and call it 5 truck vans or van trucks or what? No. But what we could do is we could add them together and we could say that we have 5 vehicles. And in saying vehicles, what you've actually done is you've created a common denominator between these two items. So I'm going to show you a couple more examples here. 4 roses plus 6 daisies. They're different types of, you guessed it, flowers. So 4 plus 6, we could say there's 10 flowers. 4 stools plus 5 folding chairs. Well, what do stools and folding chairs have in common? They're types of seats. So we could say that we have 9 seats. If we were having guests over to our house, we would be able to seat 9 people. Last one here for you, 2 sneakers plus 4 boots. Sneakers and boots are both types of shoes. So we could say we have 6 shoes. So in all these examples, we've actually created some sort of common denominator. Our denominator is no longer roses or daisies. It's something that's new. So going back to your notes packet and looking at example number 7, I have 5/8 plus 1/2. So this is like saying I have 5 trucks plus 1 van. We have to create a common denominator between these two. And what we do is we actually just look to see what are multiples of the number that would match up. So if I think about 2, I skip count by 2. 2, 4, 6, 8. And if I go by eighths, did you notice I first start at 8? We want to pick the smallest one that they have in common. So we're going to change both of these fractions so that they are now, instead of being 8 and 2, they're now both 8. Just like if they were trucks and vans, they're now both vehicles. It allows us to add them together. 5/8 is not going to change. 1/2, however, is. 2 is when you is a multiple. 8 is a multiple of 2. Sorry, flip-flopped that around. 8 is a multiple of 2. You did 2 times 4 to get to 8. Remember in our intro lesson, we said whatever you do to the denominator, you do to the numerator, and vice versa. So 1 times 4 is 4 on the top. Your denominators are the same, so you have 8 vehicles now. 5 plus 4 is 9. And like we said before, we are going to start trying to keep our answers as improper fractions unless it's a real-world example, so we're going to leave this as 9/8. So keep this in mind. Roses and daisies, our common denominator was flowers. Stools and folding chairs, seats. Sneakers and boots, well, they were all types of shoes. So we're going to look at the next page. So if you want to go over to page 6 in your notes packet, we have 3 more examples up at the top. And we're going to just, on the first one, list out some multiples to try and get us thinking. So I see 6 and 9, shoes, boots. They're not going to be the same exact thing. So if I list out multiples of 6, 6, 12, 18, 24, 30. Hopefully that's good. And now I'm going to do 9. So 9, 18, 27. Do you notice they have 18 in common? So 18 is going to be our new common denominator. 6 times 3 gave us 18. So 5 times 3 is going to give us 15. 9 times 2 gave us 18. So 4 times 2 is going to give us 8. 18 stays. 15 minus 8 is 7. Your answer is reduced, so you're good to go. This one, we have a negative here, so we're looking at this. We do have 2 different denominators, though. Think in your head multiples of 15. 15, 30. Ooh, 30 would work because that's a multiple of 10. So we're going to change this to be a denominator of 30. And we're going to actually move this negative up here with the top number. So 15 times 2 gives me 30. So 14 times 2 is 28, and we're going to make it negative. We're going to bring that negative up top. 10 times 3 is 30. 3 times 3 is 9. Denominator stays. Follow your integer rules up here. Negative 28 plus a 9 gives you a negative 19. You are reduced because the biggest common factor is 1. Number 10 is a little bit ickier here, but we see a negative fraction to start. I see a subtraction problem, so I'm going to add the opposite. So now both of my fractions are going to be negative, which means I'm going to move the negative up here with the numerators. What is my common denominator between the 3 and the 2? You said 6. You're on the right track. 3 times 2 is 6. 2 times 2 is 4, and make it negative. 2 times 3 is 6. 1 times 3 is 3, and make it negative. Keep your denominator. Negative 4 plus negative 3 is negative 7. It's improper, but we're going to leave it that way as long as it's reduced. Take a look at number 11. Omar feeds his dog 3/4 a cup of dog food in the morning, 2/3 a cup in the afternoon, and 3/4 of a cup in the evening. How many cups does he feed the dog all together? So this keyword all together tells me that I am adding. So I'm going to do 3/4 plus 2/3 plus 3/4. Look at all these different denominators. I have 4 and I have 3. I could change all of my denominators right now, or I could be smart here, and I can actually go ahead and add together the two that already have common denominators. Their denominator is 4. 3/4 plus 3/4 is 6/4 plus 2/3. Now, something else that you can do is realize this is not reduced yet. So if I reduce it, I actually get 3/2 plus 2/3, which is actually an easier problem because my common denominator is now only going to be 6 instead of it being 12. So 2 times 3 is 6, 3 times 3 is 9, 3 times 2 is 6, 2 times 2 is 4. 9 plus 4 is 13/6. We are a real-world example here, so we're not going to leave this improper this time because that just doesn't make sense to me. So what I'm going to do, 13 divided by 6 is 2. 1's left over. So he feeds his dog 2 and 1/6 cups of food. It's a word problem, so it deserves a word label. Number 12, Kim lives 9/10 of a mile from the airport and John lives 2/3 of a mile from the airport. How much farther does Kim have to travel to get to the airport than John? So we're not adding these together. To see how much farther, we're looking for a difference, which tells us that we're actually doing a subtraction problem. So we're going to start off. Kim is 9/10 and John is 2/3. So we want to make a common denominator here. What number is going to be your common denominator between 10 and 3? Smallest common denominator is a 30. 10 times 3, 9 times 3. 3 times 10, 2 times 10. Oh my goodness. It's not 10. 2 times 10 is 20. Good thing I caught that. 27 minus 20 is 7/30. And then we need a label. How much farther does Kim have to travel to get to the airport than John? 7/30 of a mile more. Or you could say farther, whichever one you would prefer. That wraps up our lesson for today with just adding and subtracting fractions. So we're looking, don't forget, anytime you're adding or subtracting fractions is to make sure that you have common denominators.